Today we're going to be looking at how astronomers in the ancient world could determine the distance to both the moon and the sun. We're mainly going to be focusing on the work of one man, Aristarchus. Aristarchus realised that if he held up a small circular disc at arm's length, it could exactly cover the moon. And he understood that there would be a relationship between the diameter of the disc and the distance between his eye and that disc, and that would be the same as the relationship between the diameter of the moon and the distance to the moon. Due to the earlier work of both himself and Eratosthenes, the ancient astronomers had a relatively accurate value for the diameter of the moon. They could easily measure the distance to the disk and the diameter of the disk, and therefore they could determine the distance to the moon. Because the proportions of these values were the same, he realised that the ratio of these values would also be the same. So let's take a look at how this could come up in a question. Here you can see an example where an astronomer holds up a small circular disc at arm's length which just covers the full moon. Let's put the values into the formula. Firstly, we need the distance to the disc, which is 37.6 centimetres. We're then going to divide that by the diameter of the disc. Now we need to be careful here. We want any values in the same ratio to be in the same unit, and you can see here that the disc diameter is measured in millimetres. So we'll change it into centimetres by dividing by 10, and this gives us 0.34 centimetres. On the other side of the equation, well, the distance to the moon is what we want to find out, so we'll call that value x. We want to divide that by the diameter of the moon, which is given to us as 3,475 kilometres. Firstly, we can solve the blue side of the equation, dividing 37.6 by 0.34, which gives us 110.588. Make sure you don't round these numbers until the end. Then we want to bring the divide by 3475 to the other side, so we do the opposite, multiply 110 by it to give 384,294.1 kilometres. For our final answer, it seems appropriate to give the value to 4 significant figures, as this was what was used in the question for the value of the moon's diameter. This gives us a final estimate of the distance of the moon as 384,300 kilometres. Aristarchus also realised that this same method could be used to determine the diameter of the Sun, once the relative distance to the Sun had been established. This is because both the Moon and the Sun subtend the same angle in the sky of around about 0.5 degrees. Hopefully this gives you a bit of a run through of how we managed to determine the distance to the Moon and the Sun. Try out the Kahoot questions and then have a go at the questions in your skills book. When you're done, mark them using the next video go through.